In early 1972, the Mars Mariner 9 satellite captured the first images of the surface of Mars. Holes like this one shown in the black and white photograph were later identified as lava tubes. Similar to those on Earth, these lava tubes on Mars are formed by molten lava and are up to 400 meters in diameter. This makes them an ideal living habitat because they provide protection from radiation and weather occurrences on the surface of Mars. The objective of this device is to be able to mine surficial and subterranean minerals in Martian lava tubes, specifically in the Hellas Planitia region, and be easily transportable to Mars and feasible for astronaut use. The device described here features a powerful drill bit that can break through basalt surface of the lava tubes, as well as a compact size and handles for ease of use by the astronauts. The primary design considerations include ease of use and maintainability with a focus on astronaut safety. Several objectives for this device are that the device will be able to collect core rock samples, collect soil samples, penetrate the ground, minimize the risk of surface operation, and withstand environmental risk on the surface of Mars. Next, you will see the design of this drill. Design specifications include both operational constraints and functionality constraints. For operational constraints, a polycrystalline diamond compact drill bit was used to penetrate the basalt surface, and the device must be able to tolerate atmospheric temperatures between -100 and 100 degrees Celsius. For functionality constraints, the drill must maintain at a constant speed of 1000 RPM, and it must be operated by a constant force of 810 newtons. Other design specifications include manufacturability constraints, maintainability constraint, and depth capabilities. For manufacturability constraints, the device must be manufactured on Earth and then sent to Mars with the crew, transport, or resupply. For maintainability constraints, the device must be easily maintainable on the surface of Mars. And for depth capabilities, the drill may extend a maximum of 6 feet into the surface, equivalent to the shaft length. The drill bit material is polycrystalline diamond, which was chosen for its high penetration rate in basalt, which is the lava tube surface material. The drill bit has a customized design inspired from Figure A, the one on the top. The drill bit is approximately 5 inches in diameter. The shaft material is grade 5 titanium, which was chosen for its strength to weight ratio. The dimensions are 5 inches in diameter and 6 feet in length. It features detachable handles for ease of use during mining operations, and there is an added lip at the upper edge for added support during shaft removal. Next, we will go into the analyses performed on this drill. Calculations were done in MATLAB for the drill bit, the bearings, and the shaft. For the drill bit, the operating force is 809 newtons, and at -60 degrees Celsius, the Mars surface temperature, the uniaxial compressive strength of basalt is 295.2 megapascals. The force, strength, and area were calculated for the drill bit. For the bearing, at a 90% reliability for 500 hours and 1000 RPM, the design life is 30 times the manufacturer's rating with a C10 value of 2.25 kilonewtons. For the shaft calculations, the von Mises stresses, alternating and mid-range stresses were calculated using the D.E. Goodman criteria to calculate failure. The graph shown here is a result from the MATLAB code of the drill bit failure analysis. It shows the uniaxial compressive strength of basalt in megapascals on the x-axis, and on the y-axis is the area of the drill bit contact in millimeters squared. As you can see, there's a blue line down the center of the graph, which clearly defines the failure region above and the operational region below. There are several design expectations for operating this drill, which include that 3 astronauts should be operating the drill, and even more would be better. The drill bit is expected to fail first based on the wear of the cutter heads, and that is expensive to build since it features materials such as the polycrystalline diamond for the drill bit head and the titanium alloy body. And our team roles are shown below.